Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Number of ways to split array, Leetcode 2270. In this problem, we are given 0 index integer array nums of length n. Nums contain a valid split at index I if the following are true. The sum of first I plus 1 elements is greater than or equal to the sum of last n minus I minus 1 elements, and there is at least one element on the right of I, that is I is greater than or equal to 0 and less than n minus 1, and we should return number of valid splits in nums. Then in example 1, nums has 4 elements ranging from index 0 to 3, and now let's try to make a split. First we split at index 0. So the 0 split will have 0 plus 1, that is 1 element on the left, and n minus I minus 1, that is 3 elements on the right, and sum of the elements on the left side will be 10, and the sum of the elements on the right side will be 3. And for the split to be valid, the sum of the elements on the left side should be greater than or equal to the right side, which is the case here. So this is a valid split. So now our valid split count becomes 1. Then we split at index 1. Now the left sum becomes 14 and right sum becomes minus 1. Since the left side sum is more than right side sum, this is also a valid split. So our valid split count becomes 2. Then we split at index 2. And now our left sum becomes 6 and our right sum becomes 7. And this time left side sum is less than right side sum. So this is not a valid split. So our split count stays 2. And finally we can't split here because there should be at least one element to the right of split point I. And now since we are done with the whole array, we will return total number of valid splits as 2. Now in terms of solution, one of the naive approach is that we iterate through all possible split points and compute the sum on the left side and right sides for each split point and check if it is a valid split. That is, left side sum is greater than or equal to right side sum and there is at least one element on the right side. But the time complexity of this approach is O of n square. This is because we have n minus 1 split points, and for each split point we are summing up the left and right subarrays, which takes O of n time, resulting in the overall time complexity of O of n square. So the bottleneck of the naive approach is that we calculate the left and right sums repeatedly for each split point. Let's take a closer look at a specific split point in the array, say between numbers 4 and minus 8. And we already have left sum and right sum for this split point. And when we move the split point to the right, we are simply adding minus 8 to the left sum and removing minus 8 from the right sum. So do we really need to calculate the entire left and right sum from scratch every time? And the answer is no. What we can do is, we can calculate the total sum, and this total sum will help us quickly derive the right sum. For example, total sum for this array is 13. And now for the first split point at index 0, we can calculate the right sum by subtracting 0th element from the total sum. For example, for this array, right sum at split index 0 will be equal to 13 minus 10, that is 3. And for the left sum, we can just add the 0th element to the initially empty left sum. So in our example, left sum for split index 0 becomes 10. So now both the operations of calculating the left and right sum takes just O of 1 time for one split point. And now we can move forward with all the split points and count the valid ones. So now let's see this in action. For split point at index 0, our left sum is 10 and right sum is 3. And as left sum is more than right sum, this is a valid split point. So we increment the valid split point to 1. Then we split at index 1 and add 4 to our left sum. So our left sum becomes 14 and we subtract 4 from right sum. So our right sum becomes minus 1. And this is also a valid split because left is greater than or equal to right. So our split counts become 2. Then we split at index 2 and add minus 8 to left sum. So our left sum becomes 6 and subtract minus 8 from right sum. So our right sum becomes 7. And since left sum is less than right sum, this is not a valid split. So our split count stays 2. And now we are done with all the split points. So we will return 2 as our answer. And now the time complexity of this approach is O of n, since we need to traverse the array twice. Once for calculating the total sum and then later to update the left and right sum and count valid split points. And the space complexity of this approach will be O of n, as we use only a few extra variables here and there. Now let's jump into the code part. First, let's initialize total sum to 0. And I am using long here to avoid overflow when summing up the large integers. Now we can loop on the nums array and add all the numbers to the total sum. Let's now initialize left sum to 0 and right sum to total sum. And number of valid splits will be 0 initially. Now we will iterate through the nums array again, except for the last one, because this ensures that at least one element remains on the right side. And now we will make the split and add current number to the left sum and subtract it from the right sum. And now we will check if the split is valid, that is, if left sum is greater than or equal to right sum. Then we will increment the valid split count. And once we are done with all the splits, we will return valid splits as our answer. Now let's submit this code. Cool. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.